Hi, great pals. Let's have a look at this question. And it says, given f of x equals to 1 x cubed. Do you see that there, it's not ax cubed plus bx squared plus cx plus d. It's just x cubed. So that's very important. That's a hint to us that already a is equals to 1. Okay, now let's continue. And g of x equals to 2. So g of x is our straight line that we have here, and f of x is our quadratic formula or quadratic function. And then it says, the graph of f intersects the x-axis at -2, 1, and 3. The turning points of f are at a and b respectively, where x of b is larger than x of a, so that we can see, all right, but this turning point is on the right and this turning point is on the left. X of b larger than x of a, which means x of b is to the right of x of a. And then lastly, it says line PQ is perpendicular to the x-axis, meaning that they have the same, perpendicular to the x-axis, meaning they have the same x values, meaning also it's parallel to the y-axis. They could have also said parallel to the y-axis instead of perpendicular to the x-axis. It means the same thing. With points P on F and point Q on G. So that's the important information that they give us here. And now it says, show that the equation of F can be given as f of x equals to x cubed minus 2x squared minus 5x plus 6. So what we already know from this equation that they gave us, like I said, is that a is 1. So they give us f of x equals to x cubed plus bx squared plus cx plus d. From this, we can say, therefore, a is equals to 1. Then they also give us, very importantly, 3 x-intercepts, meaning we have to go to the formula which states f of x equals to a bracket x minus x1, x minus x2, and x minus x3. And since we already have a, we can substitute that into our formula. Now we can say x minus, the value of x1 is -2. And a negative times by negative gives us a positive. So I'm just immediately going to substitute the positive in there. Then second bracket, x minus x2 is my second x-intercept, which we can see as 1. And x minus x3, which is lastly my third x-intercept, which is 3 over there. Okay, now you can start. I'm going to start here with my first two brackets. I'm going to times it out. If you want to bring the first bracket down and only times those two out, it doesn't matter the order. I'm going to start with my first bracket. So I'm going to say x times by x, and remember, this still multiplies with our last bracket, so it needs to be in a bracket. X times x is x squared. If you guys want to add the step where you say minus x plus 2x, you're welcome to do that, but that's just going to simplify to plus x. I want to save some time here. And then 2 times by -1 gives us -2. And lastly, we have x minus 3. So now we have a trinomial timesing by a binomial. And once again, we can say x squared times by x gives us x cubed. X squared times by -3 is -3x squared. And then we can go to our next term. X times by x gives us plus x squared. X times by -3 is -3x. And then we can say -2 times by x, so minus 2x. -2 times by -3 gives us positive 6. So now we can simplify this, adding our like terms together. We have x cubed minus 3 plus 1 gives us -2x squared. Minus 3x minus 2x gives us -5x plus 6. And if I have a look at this equation over here for f of x, it is the same one as that they gave us, meaning that we did get our correct answer. And we are very happy about that. The next question, they ask us, calculate the x coordinates of A and B. They only want the x coordinates, so we don't mind the y coordinates. But remember, A and B are our two turning points. How do we calculate a turning point? By saying the first derivative equal to 0. That gives us the x values of our turning point. So basically just testing if you guys know that we find the x value of a turning point by going first derivative equals to 0. So by 2.2 now, we have our f of x formula. So we want to find our first derivative and equate it to 0 to find the x value of the turning point. So let's go. First derivative times it to the front minus 1, 3x squared, times it to the front minus 1, negative 4x. The derivative of an x value, you just write the coefficient, the x falls away, the derivative of a constant is 0, so that falls away. And we said to find the turning points, the x values of our turning points, we take the first derivative equal to 0. Now here where you equate it to 0 is extremely important. I need to see first derivative equal to 0. Now we have to factorize this. So we don't see a common factor at all. And we can see that we are going to struggle to factorize this. In fact, we're not going to be able to factorize this without our formula. So x is equals to, you need to indicate x is equals to, you need to indicate what you are busy calculating, equals to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, I don't actually mind you writing the formula or not, because this is on your formula sheet. But I do need to see your substitution. Negative 4. Just as a reminder, a is equals to 3, b is equals to negative 4, and c is equals to negative 5 over there. So, negative 4 plus or minus the square root of negative 4 inside a bracket, very important. Otherwise, this is not going to become a positive when we square it. Minus 4 times by a times by c, all over 2 times by 3. Now, very important. Do you see that my surd or my root goes over everything that's inside of the root, and my fraction goes over everything? I don't want just like a tiny little line over there, and I don't want just like a tiny little root there. It must go over everything, and everything must be in our fraction line there. So make sure for that, please. And now all I expect of you is to type it into your calculator. So I hope you can see. Now, we're first going to put in our fraction, negative bracket negative 4, plus the square root of bracket negative 4 squared, minus 4 times by a times by c, all over 2 times by a. And you guys are going to get this. It didn't specify, but we wanted to 2 decimal places because that's what our paper indicated at the beginning of our question paper by our instructions. So I'm going to write this as 2, 1, 2, or x is equals to. Once again, do you see I indicate x is equals to or x is equals to? Please do the same. All right, now to get back here so that we can change this positive to a negative, I'm going to go right click until I reach the positive, and then I'm going to change it to a negative, and I'm going to say equals. Once again, there we now have our decimal. So I can say, or x is equals to negative 0,79. Now remember, they wanted x of a and x of b, so we clearly need to indicate which one is which. If we go back to our sketch, please remember, x is on the left-hand side, of x of a is on the left-hand side, and x of b is on the right-hand side. X of a is negative, and x of b is positive. So that means x of a is equals to negative 0,79, and x of b is equals to 2,12. And now we've answered that question. Now the last question, they want to know the graph of f is concave down for x less than k. Calculate the value of k. Now this part here where we talk about concave down, you first need to know where does our graph change concavity. So remember, concavity is by our point of inflection. And remember, for it to be concave down, it needs to end downwards. So that's why it's concave down where x is less than, so to the left of k. Now we just need to find what is k, what is the point of inflection over there. And remember, we have two ways that we can calculate the point of inflection. The first way is to take the second derivative equals to 0. Or also remember, I showed you guys a shorter method where we can say my point of inflection is where x is equals to negative b over 3a. So that's a different formula that you can use. That's much faster. So we have our a, b, and c values since we have been given this equation over here. So we can say negative bracket negative 2 over 3 times by a, which is 1. A negative times a negative is a positive, and that's going to be 2 over 3. So that's where x is equals to 2 over 3. But remember, they specified where x is less than k, and then therefore k is equals to 2 over 3 because k is the point of inflection. Therefore, k is equals to 2 over 3. There you go.